All right, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answers. So for the factoring, you're going to want to do remove, replace, reduce. So you're going to multiply by 4 and 15 to remove it. So x squared plus 17x minus 60. And then you're going to replace your 4. And that's going to be a positive 20 and a negative 3. So the first one we'll divide by 4 to make x plus 5. And then the second one will stay as 4x minus 3. And so that would be your answer. For the math knowledge question, she has a bag of 28 jelly beans, and each jelly bean is only one color. We want to know the probability that we'll pick a blue or a yellow. Well, blue and yellow, there are a total of 12 of them. So 12 out of 28, you can divide those by 4. And so if you divide by 4, that leaves 3 over 7. So that would be your probability. All right, looking at lesson 38 today, we're dealing with integral of a sum and integral of 1 over x. So hopefully you'll understand how to do integrals of sums and 1 over x after this lesson. If you have two functions and you're adding them together and you want to take the integral of them, you basically just take the integral of each one separately. Just like with derivatives, you just derive each one separately. With integrals, you take the derivative of each individually. So c is an arbitrary number, so whenever we integrate this, we're going to have a plus c, and when we integrate this one, we're going to have a plus c. But we don't have to do 2 plus c's, we can just represent all of them with a single c. So you don't need multiple c's for every term, you only need one c at the end. So we're going to integrate this. So the way you integrate integral of a sum is just to integrate each individually. So we're going to take s to the 12th and we're going to add 1 to our exponent, so that's going to make a 13, and then we're going to divide by that new exponent. So 6/13 s to the 13th. For the next term, we're going to take s to the first power and add 1 to make it a 2, and then you're going to divide by that new exponent, so 5 over 2. For e to the s, that's one that when you integrate, it's still going to be e to the s, so we're just going to have 3 e to the s. For a number, you can think of it as, not x, as s to the 0, so you're going to add 1, so it's going to become a 1 here, and then 4 divided by 1 is 4. Or you can just remember that the integral of a constant is that constant times your variable. And then we have to put a plus c at the end, and so this is how it integrates. And if you want to check it, you would just take the derivative of each term to get back to what we started with. Okay, looking at another one, we want to integrate. So we're going to do the integration of sine. So I'm going to guess that it is cosine of u. Is the derivative of cosine sine? No, but it is negative sine, so I need to put a negative. The derivative of negative cosine is positive sine. So that's that first term. For the next one, I'm going to add 1 to the exponent, so negative 5 is going to become a negative 4, and then I'm going to divide the 5 by negative 4, so it's going to become negative 5/4. The next one is e to the u. The derivative or integral of e to the u is just e to the u. So we just have 3e to the u, and then minus, when you have a number, a constant, it's just going to become 2 times the variable. So 2u, and then plus your constant of integration. So that's how you integrate sums. Just integrate each one individually. Okay? So remember that we talked about the derivative of the ln of x, or the derivative of the absolute value of x. They both went to 1 over x. So when you integrate, you have to know, are we going to pick ln of x or the ln of the absolute value of x? Since we don't know what it was originally, we're always going to pick the absolute value of x because it has a more restrictive domain for our x values. So integration of 1 over x is always going to be the ln of the absolute value of x. X to the negative 1. If you added 1 to that, it would be 0, and you can't divide by 0. So that formula that we would normally use doesn't work. But if you remember x to the negative 1 is the same thing as 1 over x, then you can integrate it as the ln of the absolute value of x. So you got to be careful on this one right here. So let's look at an example. Why don't y'all try this one by yourself and then unpause the video and see if you got it right. So for this one, we have 4 over t. So that's the same thing as 4 times 1 over t. And the integration of 1 over t is the ln of the absolute value of t. So 4 ln of t. And then 3 t to the negative 1 is the same thing as 3 over t, which is 3 times 1 over t. So we're going to have plus 3 ln of the absolute value of t. For the next one, I'm going to guess that it is 4 sine of t. Is the derivative of sine cosine? It is, so the sine stays as it is. For this next one, I'm going to guess that it's 3 cosine of t. Is the derivative of cosine positive sine? No, so I need to change the sign in front of it so that it makes it work. And then we have plus c. However, these two terms can be combined because they're both ln of the absolute value of t. So we really have 7 ln of the absolute value of t plus 4 sine of t minus 3 cosine of t plus c for your answer. So that's how you integrate sums and 1 over x. So your homework tonight is 1 through 25, so make sure to do those so that we can go over any questions you have tomorrow.